Hello everybody, welcome back to another video. In this video we're going to talk about how to solve differential equations by separation of variables. Okay, with this method our ultimate goal is to separate the variables on either side of the equation. So let's get started. In the first problem, in order to get this variable separated first, we're going to do the cross multiplication. So when I do the cross multiplication, I'm going to get e to the power of 2y times dy equals 2x squared times dx. And notice that on the left hand side we have the function in terms of y times dy, and on the right hand side we have the function in terms of x times dx, which means the variables are separated. Perfect. Alright, after we separate the variables, we're going to integrate both sides. So when I integrate both sides, I'm going to get, basically for the left hand side, I need to apply the u substitution. So if I set 2y equal to u and differentiate, we get 2 dy equals du. And from here, we get dy equals du over 2. Okay, so if I put this over into the left hand side integral, so we get and if I put the 1/2 out front, what I'm going to get is 1/2 times integral e to the power of u du equals, the integral of this expression is going to be equal to 2x cubed over 3 plus c. Okay, so we know that the integral of e to the power of u is going to be itself, so basically 1/2 times e to the power of u equals 2x cubed over 3 plus c. So I'm going to switch u back with 2y again, so it's going to be equal to 1/2 times e to the power of 2y equals 2x cubed divided by 3 plus c. So we have to get rid of this 1/2, so I'm going to multiply each side by 2, so we get e to the power of 2y equals 4x cubed divided by 3 plus 2c. Alright, so again, remember that our ultimate goal is to solve this equation for y, which means I need to put the solution in this way. Y equals f of x something plus c. Alright, so basically as you can see that the y is not by itself, so in order to get the y isolated first, I'm going to take the natural log of each side. Okay, so when I do that, this natural log and e will cancel each other out, and we're going to get 2y equals natural log 4x cubed over 3 plus 2c. Then as a last operation, I'm going to divide each side by 2. So y is going to be equal to natural log 4x cubed over 3 plus 2c divided by 2. So specifically, if I say that since 2c is a constant number, it doesn't matter in this case. So if I say that 2c is equal to this capital letter C, which is another constant, so my final solution is going to be equal to natural log 4x cubed over 3 plus c divided by 2. So that is the solution to the first differential equation. Okay, so first we did the cross multiplication. As a result of that, we got the variables separated. Then we applied the u substitution for the left hand side integral. Alright, and then we got this 1/2 times e to the power of u, and then I switched u back with 2y, and I got this 1/2 times e to the power of 2y equals 2x cubed over 3 plus c. Then I took the natural log of each side to cancel ln and e, and we got this 2y is equal to this expression. I divided by 2, and then we got this result. So this is my general solution. In order to get a particular solution to this given differential equation, we need to know the value of c. Alright, let's move on to the second problem. Okay. In the second problem, what we have, this differential equation dy over dx is equal to 2x cubed divided by y squared. So again, we're going to start off by doing the cross multiplication. So we get y squared times dy equals 2x cubed times dx. Alright, so the integral of y squared is y cubed over 3 equals x to the 4th over 2 plus c. Again, we need to get the we need to get the y by itself, like the only thing, the y. So if I multiply each side by 3, okay, to remove 3 from the denominator, we get y cubed is equal to 3x to the 4th over 2 plus 3c. Alright, and then if I take the cube root of each side, okay, and then we get y is equal to under the cube root 3x to the 4th over 2 plus capital letter C, comma, because if I set this 3c equal to the capital letter C, because these are constant numbers, it doesn't matter what they are. Alright, let's move on to the third problem. In this third problem, again, we're going to do cross multiplication, so we get e to the power of 2y times dy is equal to 2x times dx. So basically, we've separated the variables successfully, so we're going to integrate the both sides. So this integral, if you remember from the first question, it's going to be equal to 1/2 times e to the power of 2y equals, this is going to be equal to just x squared plus c. So we need to remove this 1/2. So basically I'm going to multiply each side by 2. So when I multiply each side by 2, what I'm going to get is e to the power of 2y equals 2x squared plus 2c. Then again we have to get rid of this e. So the only way to get rid of e is I'm going to take the natural log of each side. Okay, so we get 2y equals natural log 2x squared plus 2c. As a last operation, I'm going to divide each side by 2. So we get this general solution, y equals natural log of 2x squared plus capital letter C divided by 2. So that's my solution for number 3. Okay, so these are the easy type of differential equations through separation of variables. So in the next video, I'm going to be doing the medium type and hard type of differential equations by separation of variables. Alright, let's move on to the fourth problem. So again, we're going to do the cross multiplication. We get y squared times dy equals e to the power of x times dx. So since we just got the variables separated on both sides, so we're going to start integrating. So we get y cubed divided by 3 is going to be equal to e to the power of x plus c. Let me choose the different colors. I'm going to multiply each side by 3 to get rid of 3 from the denominator on the left hand side. So we get y cubed is equal to 3 e to the power of x plus 3c. As a last operation, I'm going to take the cube root of each side. So when I take the cube root of each side, what I'm going to get is y by itself equals under the cube root 3e to the power of x plus capital letter C. Alright. Okay guys, thank you so much for watching this video. In this video we've talked about 4 differential equations by separation of variables. Alright, thank you so much. If you like this video, please don't forget to subscribe, like, and comment.